Hey all, good morning, good evening, and good afternoon, guys. And thank you for taking your time on a weekend and attending this session. This was one of the hottest topic in Dreamforce this year. Glad we have Pablo over here, the same speaker and the same topic today. And yeah, let's listen from Pablo itself on this topic. Over to you, Pablo.
Yeah. All right. Thank you, guys. So just a quick intro. Obviously, my name is Pablo. I'm from Costa Rica, but I live in Dublin, Ireland. So it's 12:41 p.m. here. So as Kishore said, the session was very popular in Dreamforce. A lot of people were left outside the room, and a lot of people have asked me to repeat the session, and that's why we're doing it again today. Quick also disclaimer, this presentation is not about Salto. So Salto is my employer, but I will mention Salto twice in the presentation because it is relevant to the topic, but it's not an advertisement about Salto. So this is the same presentation that I did in Dreamforce. So just a quick introduction to Salto for those who don't know it. We do DevOps for business applications. So we obviously support Salesforce. That is our biggest business app. But we also do DevOps for other applications like Zendesk, NetSuite, Workato, Jira, and others. For Salesforce, the main features we have are dependency analysis. You can also compare orgs and deploy differences. We also have a very nice metadata editor. And we also do CI/CD. But again, it's not about Salto, so let's move on. The agenda for today is we're going to do a little bit of mandatory history on CI/CD. Then we're going to see what are the principles for creating a Salesforce deployment pipeline. We're going to see a full demo, and we're going to see a lot of code on how to do this with GitHub Actions. And then at the end, we'll see what are the patterns that emerge as we start exploring this topic. Also, this is an advanced topic, so I'm not going to be explaining what is a sandbox, what are the different types of sandboxes, what is Git, what is the metadata API. It's assumed that you already know all that, and if not, then it's still okay. But just to set the expectation that it's going to be under the assumption that you know all of that already. Okay, so let's start with the CI of CI/CD, which is continuous integration. So to understand what continuous integration is, we first need to understand the problems that it attempts to solve. So in software development, in traditional software development, and also in Salesforce, combining the work of multiple developers is hard. So in traditional software development, people use branches to isolate the work of different developers. And in Salesforce world, we use branches and sandboxes as well, right? You can have your own sandbox or a shared sandbox where you can do your own development without impacting others. The problem with that is that as the branches exist for a long time, or even the sandboxes, they start to diverge too much. They become too different from each other, where you end up having like two versions or multiple versions of an application. And this makes the merges actually very hard. And if your merges are hard, then it means that your deployment process is always unpredictable because you're never sure, if merging branches is going to take 5 minutes or it's going to be a 2 hours exercise. So with that said, continuous integration is a practice where members of a software development team integrate their work or the changes into a common branch of a version control repository. And the idea is that they do this multiple times a day if possible, or at least once a day, as frequently as possible. The idea then is that every time you submit a change to this branch in version control, there's an automated process that builds the application. It runs all tests, and it gives you a very quick pass or fail result. Pass meaning, does your change work alongside everything else that is going on, or did you break the application? It's supposed to be as simple as that, pass or fail. Now, continuous integration is actually not easy because for you to be able to get this feedback very quickly, it means you need to be able to break down your tasks into very small chunks and even deploy them or commit them in small chunks, which is very different from what we're used to doing because in Salesforce, we always deploy to the next sandbox when we're done, right? Once we have all the page layouts and all the fields and all the Apex classes, only once the feature is done do we deploy to the next environment. But in the real world of continuous integration, we're actually encouraged to deploy and commit small changes, even if it means that the feature is incomplete. Now, obviously, that sounds super weird because how can you deploy changes that, from a feature that is not complete? But then there are other techniques to go around that, which I'm not going to cover in this webinar, but we have things like branch by abstraction or feature flags as well. The other problem with continuous integration is that, as I said, you're supposed to get feedback very quickly. Did you break your application or did you break the Salesforce org? And for that, you need very good tests. If your tests are not good or if your tests take ages to run, you're going to be discouraged from committing frequently. So I'm not trying to say, the continuous integration is impossible. I'm just trying to shed some light in the fact that it's actually hard. Um, Now let's go over the CD, which is continuous delivery. So to explain what continuous delivery is, I'm going to quote Jess Humble from the book Continuous Delivery, where he says that continuous delivery is the ability to get changes of all types into production safely and quickly in a sustainable way. So in that sense, continuous delivery is not a thing that you do. It's not a product that you buy. It's not also a technique, like a technical thing you do. It's really more of a set of principles. And so the first one is just to build quality in, which it just really means fix the bugs as soon as they're found and as close to their source as possible, and ideally before committing them to version control. The next one is, as we said, work in small batches because you need to be able to shorten that feedback loop as much as possible. The next principle is about automating everything that can be automated, and that means let humans focus on higher value add activities. Finally, as I said, continuous delivery is not a project, it's not a goal that you just do and then you move on. It's a thing that you have to keep working on all the time. So there's also a principle of continuous improvement. Now, one of the patterns that emerge from the continuous delivery movement is the concept of a deployment pipeline. And in my opinion, this concept doesn't really translate too well to the way we do development in Salesforce. So I try to come up with my own version of this called a Salesforce deployment pipeline, which I'm going to define as an automated process that runs your Salesforce metadata through a series of steps, such as quality checks, tests, and deployments. And this automated process fires in response to events in your version control repository. The idea is that as your metadata goes through these steps successfully, it gives us more confidence in that this is a good implementation. And in the end, we end up with something that we feel confident that can and should be deployed to production. So the idea of this session then is to see what are the principles for creating a good deployment pipeline, and then we'll see what are the patterns that emerge from doing so. Okay, very important that these are patterns and these are not mandates. So I will be sharing some things that I think you should be thinking about, but I will try to limit recommendations because it's very hard to say, oh, you should be doing this or you should be doing that, because every Salesforce team is different, every developer knowledge is different, every org is different. So it's really hard for me to say, okay, this is what you should be doing. So instead, as I said, I'll be telling you what I think you should be asking yourself, what are the things you should be thinking about. But in the end, it's up to you to come up with those answers. So I am of the opinion that, whatever works for you, then go ahead. One more thing, Kishore, I would like to encourage people to ask questions. I don't see the chat while I'm presenting, but if there are any questions, please throw them on the chat. I don't want this to be just me just talking for 1 hour. So if there are any questions at any point, I'm more than happy to be interrupted and just have a conversation about it. But I can't see the questions while I'm presenting, so you'll have to let me know if there are any. Is that okay?
Yes, Pablo, go ahead. Yeah.
Okay, cool. All right. So the first principle is about choosing a sandbox strategy. So the sandbox strategy is how you logically organize your sandboxes. So things that you should consider is, for example, should every developer have their own sandbox, or should you use a shared sandbox? And I know some people feel very strongly about this, like, oh, well, the best practice is to have your own sandbox, and you should never have a shared sandbox. But as most things in software development, it depends, right? And so there are some projects where maybe you have 10 different integrations, and it's really hard to replicate those integrations in a developer sandbox. Sometimes it's impossible. And so in those scenarios, you may have a shared sandbox that people use when working on user stories related to those integrations. Point is, there is no right or wrong answer, but it's something that you should consider because, as you'll see later, it's going to affect everything else in your deployment pipeline. Another thing you should think about is what are the type of sandboxes that you should be using for different types of testing. And if your developers are going to have their own sandbox, how are they going to be populated with fake data? Finally, remember that in continuous delivery, there's a principle of automating everything that can be automated. So in my previous jobs, I've had really bad experiences refreshing a full sandbox where you have this huge checklist of post-refresh activities, changing email addresses, masking domains, changing integration endpoints, turn this setting off or on. I encourage you to think, how can this be automated? Because that even automating something like this is already practicing continuous delivery. So here's a typical sandbox strategy where every developer has their own sandbox. And between their own sandbox and production, there is an integration sandbox. And this is similar to that concept of continuous integration, where all the developers merge their changes into a common branch. In the case of Salesforce, the common branch is sort of the integration sandbox. Okay, the next principle is about choosing which metadata to track. So, at the core of a Salesforce deployment pipeline is having your SFDX project in Git. If you don't have your SFDX project in Git, then you just can't do CI/CD. But then this raises some questions. What metadata should be on that SFDX project? Should we track only code-based metadata like Apex classes, page layouts, Visual Force pages? Sorry, did I say page layouts? I meant Apex classes, Visual Force pages, Lightning Web Components. Um, what about changes that people made directly in production? And again, I know some people feel very strongly about this, like, oh, hold on. No one should be making changes in production. But there are some companies that they may have some specific metadata types that they allow people to edit manually to reduce overhead on the development team. And this could be things like email templates or deactivating multiple versions of a flow. So the question you should ask yourselves here is if you have those scenarios where people make changes in production, what does that mean for your deployment pipeline? Does that mean you just don't track those changes at all? Or is there some way that you can track them later on in a different way? Also, the more metadata you track in Git, in SFDX, the more knowledgeable you have to be of the Salesforce metadata API, because some metadata types are very complex, like profiles, permission sets, and flows. And it adds overhead the more you track. So if you're not an expert on the metadata API, then maybe you should start with just the code-based metadata, which is very easy to understand. What I recommend that you ask yourselves is which metadata, if I put in Git, is going to make my releases better. That's what you should be asking. Okay, the third principle is about choosing a Git branching strategy. So, the Git branching strategy is how you organize your Git branches, and this is closely related to your sandbox strategy. So, there are different things to consider here. Should I have one branch per Salesforce org? If we go back to the slide earlier, we saw that we had, like in integration, sandbox, UAT, and production. Some companies will have one integration branch, one UAT branch, and one production branch. So is that something that would work for you, or are there any? Um, is there a version of trunk-based development that would fit your needs? And trunk-based development means having one single branch. So all the developers commit the changes to that one branch, and you use that branch to deploy to all the other sandboxes. And so the cool thing about that is that you're deploying the exact same metadata to all sandboxes. So you're confident that what's in production is the same, or what's in UAT is the same thing that is in staging, and it's the same thing that is in production. So again, things to consider, no right or wrong answer. And later, if there are any questions, I can give some guidelines on maybe when you should use one or the other. Also, if you're going to be using branches, then you also need to think how do we deploy to production? Do we deploy to production from the main branch, and is that something that we do through Git? Finally, I recommend that you aim to have short-lived branches. If we go back to that concept of continuous integration, the longer your branches live, the harder it is to merge them. So whatever strategy you choose, you should consider having short-lived branches. So here's a typical branching strategy, and it's the one that I'm going to be demoing today. Basically, you have a main branch which represents production. At the beginning of the sprint, the release manager would create a development branch, and then developers create feature branches off of that development branch. And they merge the changes on the development branch. At the end of the sprint, you take development and merge it back into main, and that triggers a production deployment of everything that's on that sprint. Kishore, are there any questions so far? Any comments?
No, Pablo. For now, we are good.
No. Okay, cool. So the next principle is about choosing a
Uh,
continuous integration.
Pablo, yeah. So there's one question. So how do we do the feature branching strategy? Yeah. And that is the first step where we start the branching, right? So
Um, so I have a demo later where I'll show you how it's done, and if there are any questions after that about the same concept, we can go back to it. But there is a
sure.
demo where I'll show you exactly how the feature branch is created.
Yep.
Okay, so the next principle is about choosing a continuous integration server. I'm going to refer to it as a CI server. Now, this is one of the parts that was the most confusing to me when I started learning CI/CD, because it just wasn't clear what is Jenkins or what is Bitbucket pipelines. So the easiest way to explain it is, imagine when you're running SFDX commands on your computer, right? You're doing SFDX pull, push, or retrieve, etc. Now, what if I ask you, can you automate those commands to run later on at 7 p.m.? How would you do that? Does that mean you need to leave your computer on until 7 p.m. later? Or do you need to get another computer and make sure that it always has internet connection and that it's always on? That wouldn't make sense, right? So one of the things that the continuous integration server can do for you is that it can create a virtual machine on the cloud on demand. And this virtual machine can do a few things. It can check out your SFDX project that is in Git. Remember, continuous integration means or it relies on your SFDX project being in Git. So it checks it out and it loads it into its local file system. So then you have a virtual machine somewhere that has your SFDX project right there. The next thing that it can do is that it can listen to events in your version control repository. So it can listen to things like push or maybe pull requests or other events. And then it can respond to those events by executing commands on a remote terminal. And these are the same commands that you would be, manually typing yourself, such as SFDX commands, bash, Node.js. So this is really what a CI server does. It listens to events that are happening in Git. When something happens, it will check out your entire SFDX project and it's going to automatically run commands, just as if you were doing it yourself. And those commands would be maybe deploying to the next org, running static code analysis, etc. So here are some of the typical CI servers. Today I'm going to be demoing GitHub Actions. Okay, so this is the most important part of the presentation. So if you're feeling a little bit thinking of something else, I would encourage you to come back, because this is the most important part of it, which is deciding what to automate and when. So at the core, as I said, of a CI/CD pipeline is automating actions such as deployment, etc. So what I recommend that you do is you talk to your team and just have a conversation about what you want to automate. You don't need to necessarily know when you want to automate those things or even how they're going to be automated. Just have a conversation and say, okay, what are the things that we would like to automate in our release process? Let's say that I came up with the following. I want to automate deployments. So I want to automatically deploy the metadata to the next sandbox in the pipeline. Again, I don't know when or how, but I know that's something that I want to automate. Also, I want to give the developer the freedom to choose which tests they want to run on a deployment, whether that's all tests or just certain tests. And I want to be as automated as possible. The third thing I want to automate is I want to automatically scan the code using PMD or the Salesforce DX or Salesforce Apex Scanner to check for vulnerabilities, any issues, or code quality. Obviously, I want to do this automatically. Finally, I also just want to deploy that which has changed. And maybe this doesn't make sense for some of you who may not be familiar with CI/CD, but typically in a CI/CD flow, you deploy the entire branch to your Salesforce org because your entire branch represents, is your whole SFDX project. Sometimes you may not want to do that. You may just want to deploy that which has changed, right? If you only change one Apex class, why will you deploy the entire branch? So there are different schools of thoughts for that. But let's say that in my scenario, I only want to deploy that bit which changed. And I want to automatically figure out that which has changed. I don't want to have to specify that. Okay, so these are the things that we want to automate. The next step is to map those automations against events on your version control repository. So let's say when a pull request is open against the development branch, so from a feature branch to the development branch, I want to automatically figure out which metadata has changed or what changes the developer has made. I want to run static code analysis. I also want to do a check calling deployment to the next org in the pipeline. And I want to also run the test specified by the developer. Then when a pull request is approved and merged, I want to do a full deployment, meaning I'm going to deploy the entire branch to UAT, and that would be the development branch. And I want to run all tests. And finally, at the end of the sprint, when the development branch is merged back into main or master, I want to again take the entire branch, deploy everything to production, and run all tests. So you'll see that what we did is we thought of the things we wanted to automate, and then we mapped them against events in our version, version control repository. And this is really what your deployment pipeline is. So one of the things that I think it's important for me that you take away from this presentation is that it's very easy to just come and start putting this together. But the hard part is to think about all the other things I told you earlier. Have a, make a conscious decision about how many sandboxes you're going to have and why. Make a conscious decision about what metadata you're going to track and why. And what about changes made directly in production. So all those things are going to eventually influence how this is set up together. Okay, so enough talking. So let me actually show a demo now. I just want to see if there are any questions.
Demo. Okay, you're seeing them. Cool. Let's
Yeah, I
go
can
with
see them.
Ram.
Yeah, so why do we need to run tests, which will take a lot of time in big orgs? Yeah, so there are actually a lot of people think very differently about these things. I am with you that you shouldn't always run all tests. So, for example, if you're making a change to an Apex class that is the controller of a Lightning Web component in a community, that's a very specific change, right? If you're making just a tiny change there, why will you run tests from a completely different part of the org, like Apex triggers in like CPQ? It has nothing to do, right? And so sometimes you can be 100% sure that this change is not going to influence triggers in CPQ because it has nothing to do. So in that scenario, I fully agree and I encourage people to not run all tests. And I think Salesforce agrees with me because Salesforce gives us the ability to run specified tests. If they didn't, then then we wouldn't be having this conversation. I'm recommending that you deploy or that you run all tests in production because that's production. And it's only for this demo. You could still choose not to run all tests in production. And in my previous job, I didn't do it. I only run the tests that I knew were relevant. And if I wasn't sure, then I would run all tests. Um, okay, so Alice has a question there about what is the best way to handle situations at the end of the sprint when you're supposed to merge main to main, but some of the features changes are not ready. Right. So, Alex, I'm going to come back to that because I want the team to see the demo of how that merge happens, and then I'll come back to that question. Okay. So, I have I have two demos. They're pre-recorded, but I'll be talking through them. The first one is about how. What's that? Sorry, somebody said something.
No, no, we are good.
All right. Okay. So yeah, let me show this demo first. So the first one is how to actually set it up, how to set everything up together, and then we'll see what the developer workflow is. Okay. So the first step is to create an SFDX project and choose which metadata you want to track. So I have an SFDX project here with a package XML. And the first thing I'm going to do is I'm going to authorize it against my developer sandbox. So let's say this is the one. And then I'm going to use this really nice Visual Studio Code extension called Package XML Generator, which is going to allow me to scan my org and choose exactly which metadata I want to track in the package XML. And this goes back to that principle of making a conscious choice about what do you really want to track in version control. In this case, let's say I decided to go with the default, so I'm just going to track the code-based metadata. Once I've decided that, I'm just going to right-click here and do retrieve source in manifest from org. So this is going to do a metadata retrieve, and it's going to retrieve all this code to my local file system. So if we go here to the Apex classes, we can see them there. The next step is to commit the entire repo to GitHub. In this case, could be another thing, but I'm going to use GitHub. So I'm going to do git in and git add and then git commit just to take everything here. And then I'm going to go to GitHub and I'm going to create a repository. Then I'm going to copy the instructions. I'm going to go back to my local repository, put those instructions in. And now if I go back and refresh, you'll see that my entire SFDX repository is now in GitHub. Great. The next step is to get the authorization URL for every sandbox and store them as environment variables. So I'm going to use this command force org display, which is going to give me an authorization URL for the Salesforce org that I'm connected to. In this case, my dev sandbox could be UAT, could be production. And I'm going to copy that and I'm going to add it in GitHub as a secret. In other CI servers, it's called differently, could be an environment variable. But the idea is that you add this here as a secret so that it's secure and also so that your pipeline can read this information and automatically connect to the Salesforce org without any manual intervention. So the next step, and I'm going to actually show this myself, not through a video, is to create the actual pipeline. So in GitHub Actions, this is done using YAML, and I think most CI providers, except for maybe Jenkins, behave the same way. So this is an example of the pipeline where when a pull request is merged against the development branch, I run all these actions. And some of these actions is preparing that virtual machine to be able to do stuff, right? So for example, here I'm installing the SFDX CLI, then I'm installing Java, then I am installing the SFDX scanner. Remember, we're looking, the CI server is creating a virtual machine for us so that we can automatically run SFDX commands. And then at the end is when we can do the actual commands, like in this case, SFDX force source deploy, which is going to deploy to the next sandbox in the pipeline. Now, creating these files is actually very complicated because not only do you have to know everything that I said earlier about the principles and Salesforce and the metadata API, now you also have to know YAML and you have to know Bash and Node.js. So for this presentation, I created a free and open source tool called Naki, which stands for not another CI tool. You can access this at ci.salto.io. I'm going to repeat that, ci.salto.io. I'm actually going to throw it there in the chat. And what this does is it helps you create a pipeline in just a few clicks. So let me show you. So I go here, get started, and then I choose my CI provider. Right now, I only support GitHub Actions, but I'm working on adding Bitbucket and GitLab. So I choose GitHub Actions, then I say, okay, give a name to this job. Let's say deployment to UAT. Then we're asked, how are we going to authenticate to the UAT org? In this case, I'm going to choose the SFDX URL. Then I need to go to GitHub, create that secret, as I showed you earlier, and come back here and give the name of the secret. So in this case, let's say I called it UAT login. And then here's when we start again thinking about our deployment pipeline. What is it that we want to automate against the UAT org? In this case, I want to automate a validation deployment. Okay, and what type of deployment? Well, do you want to deploy the entire project or do you want to deploy only that which has changed? So let's say I only want to deploy that which has changed. And then when? Remember, we need to map that automation against an event in our version control repository. So when do we want to validate a deployment? Well, I want to validate it when a pull request is open against the development branch. And finally, do I want to run all tests or do I want to let the developer specify which tests they want to run directly in the pull request body? So I'm going to choose the second option. And then I can also do static code analysis and I can choose which categories. Let's say I want to do performance and security. Then you click create pipeline. And just like that, the entire YAML file has been generated for you with all the dependencies, all the things that you have to install, along with all the SFDX commands. So you don't even need to think about this. Then you just click on it, it's copied to your clipboard, and then you just go here and paste it and put it in GitHub, in the GitHub workflows directory. So I know some people are already using this in production, so it does work. So I encourage you to give it a try. It's also good for learning because you can try different combinations of the deployment pipeline and see how that affects the YAML file. Okay, so let me then go back to the second demo, which is, okay, so you set all that up. Now, how does it actually work? So let me just take some water quickly. So at the beginning of the sprint, the release manager is going to create a development branch from the main branch. That's what I'm doing here. Then every developer is going to go to their Visual Studio Code and do a git fetch, which is going to download that branch into their local. And then we're going to create a feature branch off of that branch. So I'm going to create a feature branch called feature new something. And then I'm going to choose that the development branch is the origin. That's where that's the source branch, right? Okay, so now that I've done this, I can actually start doing my changes. So in this case, I'm going to create a new method on this Apex class, and I'm going to use Visual Studio Code to deploy it to my own sandbox, right? I'm not doing CI/CD. I'm just deploying from Visual Studio Code to my own sandbox, just normal local development. I'm going to do the same for a test method here. I'm going to write it out and then deploy to my own sandbox. And once that's deployed, I'm going to run this test to make sure that it passes. And in this case, it does. So great. The next step is then to commit this branch to the remote repository. So I'm going to do git add, git commit, add a commit message. And then I'm going to use git push to push the entire branch over to my GitHub repository. In this case, I had to use a different command. So I'm going to copy that and paste it there. And once I've done that, now this branch along with my changes are in GitHub. So if I click on this URL here, I can then create a pull request from this feature branch against the development branch. So here I can now specify the changes. For example, I created a new method. Now I can specify which test I want to run. I just want to run one class as a test. So I'm going to copy the name of the class and I'm going to come back here and paste it in the pull request. I will explain how this works. Don't worry. But I'm just going to put it there. And then I can scroll down and see what are the changes that I made, right? Just like a second pass. Okay, I'm happy with the changes. So I'm going to create a pull request. Now, a pull request has been created against the development branch, and this is when the first workflow starts, right? We said that we wanted to validate the deployment against the integration or UAT org when the pull request was made. So what you're seeing here is GitHub creating that virtual machine for you, right? And installing all the dependencies that it needs to have in order to run those SFDX commands. Once it actually does that, it can then do the validation deployment. So if I go here to my integration sandbox, I can see a successful validation that happened just now. And if I see the details, I see that only two tests or two test methods were run. And to confirm that only that class was run, I can always go back to the output here, and I can see that indeed only this class was run. Great. So I know that my changes passed their test and that they integrated successfully into the next environment. That's continuous integration. Other thing we wanted to do is we wanted to do a static code analysis. So I can actually see the results directly here in GitHub. And again, all of this is configured in that YAML file. So I can go here to details and see the details of the static code analysis. In this case, it's just telling me that there's a missing parameter in the assert method. And I can always click here again to see exactly where this warning is. In this case, the same files that I changed. Now, let's say that I don't care about this warning. It's not a big deal. I'm not going to bother. So I'm just going to leave it there. And then I'm ready to squash and merge, which is going to merge this feature branch into development. And every other developer in my team is supposed to be doing the same so that the development branch represents the batch of changes for the next sprint. Now, when that merge happened, there's a second piece of automation taking place, which is now we're going to deploy the entire branch to UAT. This is sort of that second pass of continuous integration. Does everyone's changes can they be deployed to UAT? So then I can see that, in this case, it succeeded. And if I look at the details, I can see that right now all the tests were run, right, rather than just running one test. So as I said, all the developers in theory are doing this. And at the end of the sprint, if everything goes well, we are ready to merge the development branch against the main branch. And I know there's a question there in the chat about what if all the changes are not ready? I will address that. But in this case, let's say that, okay, we're ready. So we're going to merge the development into main. We're going to add a new description here, like let's say includes all changes from this sprint. If we scroll down, we can see all the commits. Ideally, one commit would represent one user story so that you can see an audit of all that's changed. And then this gives the team a final, chance to review what's going to be deployed to production in this release. So when we are finally ready, we can again squash and merge. And this is going to then merge the entire development branch against main. This is when the final workflow takes place, which is when we're going to then deploy the entire SFDX repo, meaning the entire main branch, to production run on tests. So again, virtual machine doing its thing, all the dependencies, SFDX commands. And here we have a beautiful green deployment where everything worked, which of course does not represent the real world. Okay, the last piece that I automated here is the creation of a GitHub release. This sort of gives me an audit of everything that I've done. So I can see that this production release was made on this date. I can see the commits that were deployed, and ideally, again, one commit per user story. And I can also see a zip file of the entire project. And this could help me if I want to do a rollback or if I want to check in the past, what did we deploy that time? I can just download this source code zip file and see what's there. Okay, so I spoke a lot, so give me 30 seconds to catch my breath and see if I can address the questions there. Okay, so Alice, you had asked what to do, right? If when you're merging development into main, if some features are not ready. So what you do, one of the things you could do in that case is you would create a release branch off of main So you have main and you create a release branch, and then you cherry pick the commits from development and you put them in the release branch. This is complicated because you have to make sure that the commits are added in the correct order, because some commits may depend on the metadata changed by other commits. Right? So it is not, it's not that simple. And this is one of the reasons that sometimes it makes sense to use, like an off-the-shelf DevOps platform like Salto, Gearset, Copado, etc., because we can handle all that complexity for you. But the gist is that you create a branch off of main and you cherry pick which are the commits that you want to deploy. Oh, and also that would only work if each commit represents a user story. Otherwise, it gets a lot more complicated. Ankush has a question about SFDX versus ANT metadata. I haven't used ANT in like 2 years, so I would say definitely go for the SFDX CLI, just because it's the current one, is the one that Salesforce is always updating and introducing new features. And I know there are some rare scenarios where things cannot be done with SFDX CLI, and you need to use ANT for that. But I would say only do it once you hit those scenarios, which I don't know which ones they are. I just know from conversations I've had with people. Um, Paul is asking if there are any costs in using the Naki tool. No, this is 100% free. As you can see here in big letters here, it's free. This is a gift from us to the community because we want to make the creation of CI/CD pipelines a lot more accessible. Um, so Sam is asking, how am I creating the automatic YAML files here? Yeah, so what I did is I first created this YAML file manually a long time ago. And then when I was preparing for my presentation, I realized, hey, there's a better way to do this. So what I did is I took this YAML and I went to a website where you can translate a YAML to JSON. And then what my app is doing is creating that JSON file or that JSON object. I use as you start populating, the pipeline configuration, I start storing configuration details. Then I create this huge JSON object, and then I use a npm package to translate that JSON back to YAML. So it's kind of, first I have to have a working YAML file that I'm confident that it works. And then I need to include that into my app as a JSON object and then convert it back to YAML. Christian has a question. Which of the principles and considerations for your Salesforce deployment pipeline? Uh, Sorry, Christian, do you want to ask that question directly?
Yeah, rereading it, I can see it's a chunky sentence, right? But I'm just the gist of it is what you show here. How much of this is typically covered, in your opinion, from the commercial off-the-shelf tools, Gearset, Copado, Salto, and how much of this would be like a homegrown setup that you're providing a recipe for, if that makes sense?
Yeah, I think, for example, the things where it makes sense to use a vendor, and actually I have a few slides about that, is like the question earlier: how do you merge changes, or how do you merge a branch with changes that are not complete?
Mm,
That exercise of cherry picking can get messy very quickly. So that's one of the things that I would expect any DevOps vendor to automatically do for you. Also, a lot of the principles that we saw are more about how you think about your org, right? How are you going to organize your sandboxes? What metadata you want to track in Git? These vendors should also give you a choice on what you want to track in version control, as far as I know. So a lot of these principles are more about your thought process, right? And it's relevant whether you use your own homegrown system like I've had, or if you use something like Salto, Copado, or Gearset. Uh,
cool,
I don't know if that answers your question.
100%.
Okay.
Thanks.
So Alice said use squash and merge to main. That's going to join the whole sprint into one commit. Yes, it will. Um, yeah, that's true. it would just show it would squash all the commits and just have one there, which you could then argue that doesn't make sense because then you lose the history of the commits. But I do have it on the release, right? If I go here to the release, I do have the commits where ideally each commit is like one user story. But that is true. Let me see, because I did squash and merge. Yeah, so that is true. If you squash and merge, then you lose that history here. So maybe you don't want to squash and merge. So good point. Um, Ram is asking, what if we deploy only the delta instead of full? Uh, that's what I used to do in my previous job. I only deployed the delta. So the theory here, why would you deploy the entire branch versus the delta? If you deploy the entire branch, you're making Git your source of truth, because it means that you're happy to deploy you're happy to deploy everything that's in Git because you know that is the source of truth. If you make a change in production manually and then you deploy everything from Git, you may override, well, you will override that change. And so the question that I would ask a team is, let's say you did your sprint 1 week ago, right? You deployed a lot of metadata last week. Are you confident deploying that branch again to production right now? If I asked you, hey, can we deploy the entire branch back to production? If you are like, whoa, hold on, that means that Git is not your source of truth, right? Because you are not sure if there are any changes that happen in production since the last time you deployed. And that's okay. Like, maybe you don't want Git to be your source of truth. Maybe you're not ready for that. Maybe your team is still ramping up on Git. So that's okay. And I'll show you how I did the Delta. It's a package that it's like a free SFDX plugin. Is super popular, which it only means there's a lot of people wanting to do Delta deployments. Um, Mohammed is asking, how do you deactivate flows? I will come back to that in a moment. And Virendra is asking, can you please share an easy rollback automation plan? And build pipeline will connect to release pipeline. So yes. Okay, let me finish because I do have a few more things and I'm conscious that it's almost 1 hour. So I'll come back to these questions in a moment. Okay. So how did I do a few things? So this is how I authenticated to the Salesforce org. I used the SFDX authorization URL. I added that as a secret in GitHub, and then I run this command, SFDX SFDX URL store, and then I look at that file, and that's going to just authenticate to that org. That's a lot easier than using a JSON Web Token flow, where you need a connected app in each sandbox. Also, how did I let the developers specify which task they want to run in the pull request is I came up with this syntax, apex : bracket, and then the name of the class. You can add multiple classes as well, separated by a comma. And the way that works is my pipeline has a script. Actually, let me show it live because it's probably easier. So, So the pipeline has a JavaScript file here. And this is kind of Node.js. So this Node.js is going to read data off of the pull request. However, what if this file is not here? Because when you create the pipeline using this Naki tool, and if you choose to do this, where developers specify the data in the pull request, you have to put that JavaScript file in the root of your directory. And I'm telling you that here. But if you forget, then I don't want the whole pipeline to just break. So what I have is in my YAML file, I have this logic that says, look for a file called parse pr.js. If it exists, then take the pull request body and put it on this file, and then use Node.js to execute that JavaScript file. If it doesn't exist, meaning you forgot to include that file or it has a different name, like in this case, it has a different name for me, then it's not going to find it and it's just going to default to run all tests. And what it does is, regardless of which one you do, you put those tests, those actual names, which are you get from this JavaScript file by looking at the that delimiter and then just looping through each line. Once it has those names, it puts them into a GitHub environment variable called Apex test. And then later, when you do your actual deployment, you check here. Um, if it does not equal all the value of this variable, then use run specified tests, and here pass those specific tests. If it equals all, which means maybe the developer didn't specify any changes or any test, or that file was not found, then just use run local tests. So that's how I did that. Finally, how did I generate the Delta deployment? There's a SFDX plugin called SFDX Git Delta, which can check the difference between two commits, and it creates a folder called change sources. And then in your deployment in SFDX deploy, you point to this new folder. Now, I do have a few slides on when to use a DevOps platform. And in this case, obviously, I'm going to use Salto. So there are some limitations with this approach, right? Let's say if you're doing CPQ, I don't know if anyone here has worked with CPQ, but CPQ data is data that should have been metadata. If you know the CPQ data, it's like, price conditions and configuration attributes and all this stuff that should have been metadata, or at least should have been metadata types, but it's not, because CPQ was created years ago as a managed package. But this is data that actually influences the runtime behavior of CPQ. So it's actually metadata. It's not customer data. So without a tool, you can't include this metadata in your CI/CD pipeline. You have to deploy this manually with data loader or something else. And so in Salto, one of the things that we can do for you is we can take any data and transform it to this format called NACL, which stands for Not Another Configuration Language. And so your data and metadata become the same format, which is kind of like a JSON object here. And we can include this data in your CI/CD pipeline. So what you're seeing here is a pull request from a feature branch of CPQ changes against main, and we can see what are the changes that are here. Obviously, in Salto, behind the scenes, we figure out, is it data or is it metadata? And then we deploy it automatically using the relevant APIs. But doing this yourself is going to be really, really hard. I mean, Salto has a whole team of developers who did it, right? Another reason to use a DevOps vendor is, as I said earlier, some metadata types are very complex. So if you've ever compared flows or profiles in Git, it's really hard. So in Salto, we offer kind of like a document UI. So what you're seeing here, I know it's very small, but what you're seeing is the differences of a flow. And as you can see, it just looks like a Google Doc, where the green stuff is things that have been added and the red stuff is stuff that has been removed. Also, another reason you may want to use a DevOps platform is to allow admins and developers to use the same mechanism, right? Because all the stuff that we did here is super technical. And then there's this question about, what about admins? If an admin is creating a custom field or some flow, how do they include that in the pipeline? And your options are either learn Git, your admins need to learn Git, which many don't want to do, or just don't have that in the pipeline. And with something like Salto, what we do is we give you a CLI that you can use in your pipeline. And if you create a pull request with that CLI, those pull requests will show up in the UI, and then admins can come here and include their changes as well. Finally, it's really hard to deploy Salesforce metadata sometimes. There's a lot of different errors that can happen. So we also know a lot of those errors in advance, and we can warn you before you do deployments. Okay, so I know I spoke a lot, right? And this is supposed to be about design patterns. And really, what we've seen so far is just a lot of principles. But when you start going through these principles, you realize that there are actually some patterns that you can choose depending on how you want to model your CI/CD strategy. So this is just going to be a recap. We already went through all this, but now we're looking at it through the lens of patterns that you can choose depending on your needs. So for your sandbox strategy, the different patterns are using a shared sandbox where everyone has access to the same sandbox, everyone is developing there. You use another pattern is to use an individual sandbox, meaning everyone has their own sandbox, or also a hybrid. As I said earlier, maybe there's a project that has a lot of integrations, and for that project, you have to use a shared sandbox. But for everything else, you could use maybe a personal sandbox. The next pattern is about source control is what are you going to have in Git? Are you going to track everything, even email templates and reports and all, or are you just going to track code-based metadata, right? So you can choose which one you want to do. When it comes to branching strategies, you have different patterns like the Git flow strategy, which is the one that I showed. You also have the one org per branch, which I did not show, like one UAT branch, integration branch, and production branch. And then you also have the pattern of a one branch, which is a version of trunk-based development. For deployment, your patterns are either you deploy the entire repository if you're confident that it should be the source of truth. If you're not confident, and that's fine, or if you want to reduce deployment times, you can use a Delta deployment. For choosing a CI server, you can use something that is built in. So in this case, I use GitHub Actions, which comes with GitHub. You could also use Bitbucket pipelines, which comes with Bitbucket. There are other servers that are a separate software. So stuff like Jenkins or Circle CI, that's a different piece of software that you have to buy, you have to manage. So you also need to think about which one would make sense for me. For running all tests, your patterns are, as we discussed earlier, either you run all tests or you run specified tests. You also have to have consider the patterns for what is that trigger in your CI server. Is it when a branch is created? Is it when a pull request is created? Maybe when a pull request is merged, or when you do a push. Obviously, this is misspelled here, and this is the third presentation that I do where I forget to correct this to push. But I think I'm just gonna leave it like that. And then the final pattern is about your CI/CD solution. Are you going to do everything yourself, like I did here, which works, or eventually you may hit some limits, where again you need to deploy configuration data. It's hard for admins and developers to collaborate. It's hard to pick and choose which features to deploy to the next environment. So when you start getting into those problems, you may want to consider using a third-party platform, again, like Salto, of course. So finally, I just want to say that I talk a lot about CI/CD. There's a lot of things that I didn't say here because we will be talking for like 2 hours. So I have this thing on LinkedIn called CI/CD Weekly, where I share tips about CI/CD, and the comments are always very interesting. A lot of people engage, and we have very long discussions. So if you want to learn more about CI/CD, I would encourage you to follow me. And that's it. Thank you so much for listening. Okay.
Great
Um, let
session,
me
Pablo.
thank you, Kishore. Let me go back to the questions very quickly. I know we're really out of time, but I don't mind. So, how to automate the deactivation of flows, and how to do Delta deployment. I already showed you how to do Delta deployment, Mohammed. So you use that SFDX Git Delta, um, which again, it's a package, or it's like a SFDX plugin. How to automate the activation of a flow? That's interesting. You could actually use, don't know if how to pronounce it. I think it's Puppeteer or Puppeter. It's a Node.js library that allows you to automatically do some UI actions. So there is a there's this plugin for SFDX called SFDX TechSay. TechSay is a consultancy in France. So they have a wrapper around the SFDX CLI, and they have a lot of commands to do stuff that it would be impossible to do or you will have to do manually. For example, there's I saw one the other day, this one here. So they have a command to trigger the calculation of sharing rules, and that's not something that you can do with the Salesforce CLI, but they have it here, and you can look at the code to see what they do. And what they do is, again, this is a Salesforce DX plugin, and it's using this Puppeteer library, where eventually this creates kind of like a virtual browser somehow. As you can see here, browser new page, and then it logs into the org, and it opens that page where you can calculate sharing rules, and it actually clicks on that button for you. It's really cool stuff. So I recommend that you look at this. So I'm going to put that on the chat. Hopefully that answers your question. Birender asks, can you share an easy rollback automation plan? That's another reason you may want to go for a DevOps vendor. DevOps vendor is we may be able to do it a lot easier for you. Rollback, it depends, right? Do you want to roll back everything or just one feature, right? Because if you deploy the entire development branch, which has all the features from that sprint, and then one feature goes wrong, you need to think, well, do I really want to remove all the other features just because of one? So again, it gets messy. You may want to create like a hotfix branch off of main and somehow remove that commit and then deploy that. Or you may think about if there are features that are very complex, can you hide them behind a custom permission, or can you hide them behind a custom metadata type? And this is the concept that I said earlier, way earlier in the conversation, which is kind of like a prerequisite for doing continuous integration the right way, which is branch by abstraction or feature flags. So you can, there is, if you search for feature flags, there's this article from Martin Fowler which explains the whole pattern, which is essentially how to turn off and on automation directly in production. Obviously, here is with some code, but in the case of Salesforce, we can do it with code, or we can do it with custom metadata types or custom permissions. That may help you roll back a feature without actually rolling back the entire deployment. So hopefully that makes sense. I'm going to drop that there.
Thank you, Pablo.
No worries. And let me see. Sam had a question. Build pipeline will connect with release pipelines. If so, how? Sorry, Sam, I don't understand your question. You want to unmute yourself and ask again?
Yeah, hi Pablo. Actually, I was trying to ask about the same. Is build pipeline is different and release pipeline is different, right? So, is there any chance for connecting between these two, build pipeline and release pipeline?
I'm not sure I understand the. I'm sorry. I'm not sure I follow you. So what I showed earlier is
Mm-hmm.
like this deployment pipeline. This is how you release and deploy stuff to different orgs. Do you want to expand on your question, or you can also ping me on LinkedIn later, and you can ask me directly if you want.
Yeah.
Um,
Okay. Yeah. Thank you.
that's actually a good thing. So I'm gonna put my LinkedIn here if you guys want to again follow me. And also, please, I love talking about CI/CD. So Sam, if you want to reach out later, well, not later, maybe on Monday, but if you want to
Yeah. Yeah.
reach out
Sure.
on Monday, and we can schedule a call, I'm more than happy to talk to you, because the more I talk to people, the more I learn. So I just put that link to my LinkedIn there. I think we're done with the questions, right? There's one from
Sure.
Alice.
Thank you.
Yeah. Okay, I think we're done. Ankush, you have a question about SFDX CLI versus Ant metadata? Do you want to unmute yourself and maybe ask out loud?
Yeah, so we have SFD CLI, which is a new, and the old is the Ant metadata tool. So generally, most of the old enterprise organization use the Ant still. So switching over the SFDs like still not everyone is confident about. And so like, is it more speed or more provide more feature than the Ant tool?
It will definitely has a ton more features, right? And especially if you use something like this uh, TechSafe plugin, which is again like a layer on top of that, you can automate so many more things, and it's just a lot more easier to work with. If you are not if you're not yet using SFDX CLI, I highly recommend that you try to book some time to really learn it, because it's very very different, and it's, to
To
me,
me,
it's
it's
much,
much,
it's much
and
better.
Salesforce is also investing a lot.
Yeah,
Yeah,
the
the
Salesforce
Salesforce.
is not going to invest at all in the and the
So
API or whatever you call it. So if it breaks, then I'm sure no one's going to help you.
correct. Great, guys. I think thank you, Pablo, again. So it was wonderful session from you on the design patterns of CI/CD.